Now, these next studies detailed in section 12.4, that's on page 501, they illustrate that we can inhibit people's, the Whorfian effect, essentially, by inhibiting people's linguistic processing. So, so there's sort of a circuit in the brain where we can, it's called a phonological loop, and it's a circuit where we can repeat over and over again in our minds numbers or words or stimuli in over and over again to keep them activated in short-term memory. This is how we remember phone numbers from the time we look at them in the phone book to the time when we dial them on our phone. We just say the number over and over again in rapid succession until we're able to dial it. That's the phonological loop. Well, when you activate the phonological loop, when you fill it with something, it essentially is activating the language centers of the brain, and it's occupying them so that something else can't occupy them. So when researchers gave a set of numbers to participants and told them that they needed to remember these, it's a memory task, say these over and over again to yourself, and then they gave them the color trio test, the difference between Russians and English speakers disappeared. That suggests that if you're allowing people to use the language centers of their brain, then they can see the difference between the light blue and the dark blue faster in Russian than they can in English. But if you're occupying their language centers with something different, then they can't latch on to the linguistic categorical difference between the light blue and the dark blue. And that means then that they're no better at perceiving the difference between these colors than our English speakers. Another piece of evidence that suggests that this effect is dependent on access to the language centers of the brain is illustrated on the bottom of page 502 and 503. Here we see that we have to recall that the language center of the brain is almost always in the left hemisphere. If you recall split brain patients, when they had their corpus callosum severed and you would present information to one hemisphere or the other, or to one visual field or the other, then the information presented to the left visual field would go to the right hemisphere of the brain. And in the right hemisphere of the brain, since the corpus callosum was severed, there was no way for the information to cross that barrier into the left hemisphere of the brain. If it can't cross to the left hemisphere of the brain, then it cannot have access to the linguistic centers of the brain. So anything presented in the left visual field can't be processed by language centers. Now, we can see a similar effect in everybody, even those who don't have their corpus callosum severed. We can still see that information presented to the left visual field takes longer to process linguistically because it goes first to the right visual field, then across the corpus callosum to the language centers. But information presented in the right visual field goes directly to the left hemisphere where the language center of the brain is and is processed immediately by the language center. So there's no delay. It's faster to present something linguistically speaking. It's our linguistic process, I should say, processing is faster if you present it to the right visual field. So what we see here is that when participants were given the odd color out, you can remind yourself of what that looks like if you go back to page 500. It's figure 12.9. If participants were presented with that task to only one visual field and not the other, then they were faster to make that distinction if the distinction between green and blue, if they were shown that in the right visual field, but if they were shown in the left visual field, then they were slower, suggesting that this ability to distinguish between the green and the blue depends critically on the language centers of the brain. So, all told, do color names alter the perception of color? Yes, but only if people can access or activate those linguistic labels while they're trying to do the task. Otherwise, it doesn't really make any difference. yeah, so that's the research on color perception and the Dwarfian hypothesis.